Picture this standing on a windswept plain thousands of years ago, gazing up at a sky so vast and unpolluted that the Milky Way stretched like a river of light overhead. No city glow, no artificial haze, just the raw, unfiltered cosmos, pulsing with secrets waiting to be decoded. This was the canvas ancient astronomers worked with, and what they achieved with nothing more than stone, shadow, and sheer ingenuity will leave you speechless. Across continents and cultures, from the deserts of Egypt to the jungles of Mesoamerica, our ancestors built observatories so precise they could track planetary movements centuries into the future, long before telescopes or satellites existed. Some of their calculations were so accurate, modern astronomers still double-check their math. What if I told you there are ancient structures still standing today that knew the dance of the stars better than many of our textbooks? Places where the walls themselves are celestial calendars, where doorways frame the rising sun on the equinox like clockwork, where shadows creep across stone to mark the seasons with pinpoint accuracy. These aren't just ruins, they're time capsules of cosmic wisdom, left behind by civilizations that turned the heavens into architecture. And here's the wildest part. We're only just beginning to understand how deep their knowledge truly went. Some of their discoveries contradict what we thought we knew about history, science, even human potential. So how did they do it? No computers, no star charts, no space probes, just naked eyes and relentless curiosity. Over the next 26 stops on this journey, we'll walk in the footsteps of these sky watchers, from the towering ziggurats of Babylon to the haunting stone circles of Britain. You'll witness how a temple in India predicted eclipses down to the minute 2,000 years ago, how a desert fortress in Peru mapped the constellations with uncanny precision, and how a Celtic tomb became a winter solstice calculator. By the time we're done, you'll never look at an old stone the same way again, because these aren't just rocks. They're humanity's first telescopes, our original mission control, proof that the drive to explore the universe is written in our DNA. The night sky was their internet, their library, their compass, and they cracked its code with nothing but patience and perseverance, ready to see how. Let's begin. To understand why ancient observatories mattered so much, you have to step into the minds of people for whom the sky wasn't just a spectacle, it was survival. Imagine being a farmer in ancient Egypt, where the Nile's floods meant life or death for your crops, or a Mayan priest determining the exact day to plant maize so the rains would come. These cultures didn't just watch the stars, they lived by them. That's why their observatories were so precise. Take the Maya, for example. Their pyramids weren't just tombs or temples, they were giant celestial calculators. The steps of El Castillo at Chichén Itzá are designed so that during the equinoxes, the setting sun casts a shadow that slithers down the staircase like a serpent, a deliberate, jaw-dropping alignment with the cosmos. But it wasn't just about agriculture. These structures held power. In Babylon, kings used astronomical predictions to legitimize their rule, claiming the gods spoke through the stars. When an eclipse loomed, it wasn't just a light show. It was a political tool. Priests who could read the sky held sway over entire civilizations, turning celestial events into messages from the divine. And let's not forget the spiritual side. For the ancient Egyptians, the alignment of the Great Pyramid with Orion's belt wasn't an accident, it was a stairway to the afterlife. Every solstice, every eclipse, every rising star was a conversation with the gods. What's truly mind-blowing is how they pulled this off without a single telescope or calculator. They used shadows, sightlines, and painstaking records carved into stone. The Nabta Playa in Africa, older than Stonehenge, features megaliths arranged to track the summer solstice sunrise, proof that even 6,000 years ago, humans were mapping the heavens with nothing but rocks and patience. And in Cambodia, the temples of Angkor Wat are aligned so precisely that during the spring equinox, the sun rises directly over the central tower, a feat that required centuries of observation. These weren't just buildings, they were libraries of light and shadow, built by people who understood the sky's rhythms better than we do with all our technology. So why does this matter today? Because it rewrites what we think we know about human ingenuity. These observatories weren't primitive, they were masterpieces. They remind us that curiosity and precision aren't modern inventions. They're etched into our bones, as old as the stars themselves. And when you stand in one of these places, under the same sky they studied, you're not just looking at ruins. You're standing in the control room of humanity's first space program. Standing like sentinels on England's Salisbury Plain, the towering stones of Stonehenge have whispered celestial secrets for millennia. This isn't just a ring of rocks, it's a Neolithic supercomputer, engineered with such precision that its builders could pinpoint the solstices down to the minute. On the summer solstice, the rising sun pierces perfectly between the heel stone and the central altar, flooding the inner circle with golden light. 6 months later, during winter solstice, the sun sets precisely between two towering trilithons, as if the stones themselves are cradling the dying light. But here's what most people miss: Stonehenge isn't just a solar calendar. Those seemingly random smaller stones, they form a sophisticated lunar observatory. Archaeoastronomers discovered that certain alignments correspond to the moon's extreme positions in its 18.6-year cycle, allowing ancient sky watchers to predict eclipses with startling accuracy. Consider this: the builders hauled 80-ton bluestones over 150 miles from Wales, shaping them with nothing but stone tools and brute strength. Why go through such monumental effort? Because to them, this wasn't just architecture, it was sacred cosmology made physical. The arrangement mirrors celestial patterns, with the outer ring representing the sun's annual journey and the inner horseshoe echoing the moon's phases. Even the avenue leading to Stonehenge aligns with both the solstice sunrise and the constellation Orion, mirroring the celestial pathway ancient Britons believed souls traveled after death. Modern laser scans reveal hidden carvings of daggers and axes on the stones, not random graffiti, but likely ritual markers tied to astronomical events. What's truly humbling is realizing how much we still don't understand. The recent discovery of Durrington Walls, a massive Neolithic settlement near Stonehenge, suggests the entire landscape functioned as one giant observatory. Timber circles aligned with winter solstice sunrises, while processional pathways mirrored the Milky Way's curve. Forensic soil analysis shows people feasted there during midwinter gatherings, turning celestial events into communal celebrations that united scattered tribes. This changes everything. Stonehenge wasn't an isolated temple, but the beating heart of a ritual landscape where sky, earth, and humanity converged. Perhaps the greatest mystery isn't how they built it, but why they needed such precision. Some scholars believe Stonehenge functioned as a celestial, early warning system, its eclipse predictions allowing priest astronomers to prepare communities for omens that might cause panic. Others argue it was a healing site where the solstice alignments created sacred geometry believed to harness celestial energy, what we know for certain. These Neolithic engineers achieved something modern astronomers with satellite data still marvel at. They turned cold stone into a living dialogue with the cosmos. Every chisel mark, every alignment, every sacrificed artifact found buried beneath the stones whispers one undeniable truth: our ancestors didn't just observe the sky. They spoke its language fluently. High above the jungle canopy of Mexico's Yucatan Peninsula, the El Caracol Observatory at Chichén Itzá stares at the sky like a stone eye frozen in time. This isn't just another ruin, it's a masterpiece of celestial engineering, a spiral-shelled tower where Mayan astronomers decoded the cosmos with nothing but naked eye observations and sheer brilliance. The name El Caracol means the snail, a nod to its coiled staircase, but don't let the whimsy fool you. Every curve, every window, every step was placed with surgical precision to track Venus, the brightest planet in our sky and the Mayans' most sacred celestial body. Why Venus? To the Maya, this shimmering world wasn't just a point of light, it was the god Kukulkan, the feathered serpent whose movements dictated war, agriculture, and even royal coronations. El Caracol's narrow slit windows align perfectly with Venus's extreme rising and setting points over an 8-year cycle, allowing priests to predict its appearances down to the day. But here's what's truly staggering. Their Venusian calendar was off by just 2 hours per 500 years. Modern astronomers with supercomputers would tip their hats to that kind of accuracy. The genius lies in the details. The observatory's base isn't perfectly round, it's slightly oval, compensating for atmospheric refraction that bends starlight near the horizon. The main staircase points exactly toward the northernmost setting of Venus, while diagonal sightlines through the windows frame the planet's southern extremes. Even the building's slight tilt mirrors the ecliptic plane, the sun's apparent path across the sky. This wasn't guesswork. It was the product of centuries of meticulous record-keeping, with Mayan scribes noting celestial events in codices so precise they could retroactively calculate eclipses that occurred before their civilization existed. Now look beyond El Caracol to the larger site. The Pyramid of Kukulkan, just a stone's throw away, transforms into a celestial serpent during equinoxes as sunlight slithers down its steps, a visual echo of Venus's journey. Nearby, the Temple of the Warriors aligns with the Pleiades, a star cluster the Maya associated with rain and planting seasons. Every structure at Chichén Itzá whispers the same truth. This was a city built by the sky for the sky. What modern scientists took decades to reconstruct with telescopes and algorithms, the Maya deduced simply by watching shadows crawl across stone. They didn't need lenses or satellites. They had patience, generations of shared knowledge, and an unshakable belief that the heavens held the blueprint for life on Earth. When you stand in El Caracol's shadow today, you're not just seeing an old building. You're standing inside the mind of a civilization that turned the night sky into a sacred clock, one that still ticks with flawless precision. Buried in a German forest for over 3,600 years, the Nebra Sky Disk shattered everything we thought we knew about Bronze Age Europe. This 12-inch bronze circle, inlaid with gold symbols, isn't just art. It's the world's oldest known portable star map, a handheld cosmos crafted 16 centuries before the Common Era. Picture a farmer or priest holding this gleaming disk aloft, aligning its gold crescent moon and sun with the real sky to predict solstices, planting seasons, even eclipses. The precision is breathtaking. The cluster of 7 gold dots, that's the Pleiades, the same star group the Maya tracked half a world away. The arcs along the edges mark the solstice sunrises and sunsets with an accuracy that would require generations of naked eye observation. But here's where it gets eerie. When archaeologists first studied the disk, they assumed it was a simple calendar. Then they noticed something chilling. The angle between the solstice markers matches only one location, the Mittelberg Hill where it was found. This wasn't a generic tool, it was custom built for that specific patch of Earth, suggesting the site itself was sacred. Forensic analysis revealed even darker secrets. The disk was buried with 2 swords, axes, and bracelets, likely offerings to the gods. Gold traces on its surface hint it was repeatedly touched or rubbed during rituals, as if the act of holding it channeled celestial power. The craftsmanship alone rewrites history. The bronze came from the Alps, the gold from Cornwall, proof of a vast trading network spanning Europe. But the real shock came when researchers realized the disk wasn't made all at once. It evolved over centuries, with layers added as astronomical knowledge grew. The earliest version tracked basic solar cycles. Later, someone added the Pleiades to sync it with lunar months. Finally, a sunboat appeared at the bottom, a mythological vessel believed to carry the sun through the underworld at night. This wasn't just a tool. It was a living document, updated like software across generations. Why does this humble disk append so many assumptions? Because before its discovery in 1999, scholars believed Bronze Age Europeans were too primitive for such sophisticated astronomy. Yet here's proof they mapped the heavens with the same rigor as the Egyptians or Babylonians. The disk even encodes a 19-year metonic cycle. The time it takes for moon phases to repeat on the same calendar dates a concept later credited to the Greeks over a millennium later. What rituals unfolded under its gaze? We can only imagine ceremonies where torchlight danced across its gold inlays, where priests chanted as the Pleiades rose in alignment. One thing's certain, the Nebra Sky Disk wasn't just observing the cosmos. It was a bridge between Earth and sky, a talisman that turned celestial patterns into something you could hold in your hands. In an age before writing, this was their sacred text, written not in words but in starlight and gold. The Great Pyramid of Giza doesn't just dominate the desert skyline, it commands the cosmos. While most marvel at its sheer scale, the real genius lies in angles so precise they defy belief. The pyramid's base aligns with true north to within 1/15 of a degree, an accuracy unmatched until modern GPS. To put that in perspective, even the Royal Observatory in Greenwich, built 3,000 years later, has a slight deviation. How did ancient Egyptians achieve such perfection without compasses or satellites? The answer might lie in the stars themselves. Look closer at those narrow shafts angling through the pyramid's core. Far from simple ventilation channels, they point like celestial arrows to key stars in the ancient sky. The southern shaft in the King's Chamber targets Orion's belt, the very constellation Egyptians associated with Osiris, god of the afterlife. Meanwhile, the northern shaft locks onto Thuban, the pole star of their era. This wasn't random. At certain times of year, these shafts would have funneled starlight directly onto the sarcophagus, as if guiding the pharaoh's soul to the heavens. Some researchers believe the entire pyramid functioned as a monumental star clock, with solstice sunlight striking specific corners to mark the turning of seasons. But here's where it gets controversial. While mainstream archaeology insists the pyramid was solely a tomb, the math tells a different story. The ratio of its height to perimeter mirrors the Earth's radius to its circumference, a relationship no civilization should have known in 2500 BC. Its latitude coordinates happen to match the speed of light when converted to modern units, a coincidence, but a spine-tingling one. And then there's the descending passage, angled 26 degrees, the exact slope needed to observe the pole star from Giza's latitude. Too many accidents pile up. Perhaps the truth lies in duality. The pyramid was a tomb but also a cosmic machine. Imagine priests in its inner chambers tracking Sirius's heliacal rising, the event that heralded the Nile's life-giving floods. Or visualizing the entire structure as a 3D map of the northern sky, with its apex as the celestial pole. Even the choice of Giza's plateau feels intentional, the high ground offering unobstructed views of the horizon for stellar observations. What's undeniable is this: the builders encoded astronomical knowledge into stone with a precision that humbles modern engineers. Whether it predicted solstices, aligned with constellations, or served as a spiritual gateway, one thing's clear: the Great Pyramid wasn't just built for the Earth. It was a bridge to the stars. Perched on a knife-edge ridge in the Andes, Machu Picchu doesn't just overlook the clouds, it communes with them. At its heart stands the Intihuatana, a carved stone pillar so precise it's often called the hitching post of the sun. But this isn't just a pretty relic. On the equinoxes, the pillar casts no shadow at noon, a feat of engineering that required the Inca to understand the sun's path with near mathematical perfection. They didn't just observe the sky, they conversed with it using stone as their language. Walk through the ruins today, and you'll notice something extraordinary: every major structure aligns with celestial events. The Temple of the Sun's trapezoidal window frames the June solstice sunrise, bathing its altar in golden light. The nearby Torreon Observatory tracks the Pleiades, whose rising signaled the Incas' planting season. Even the city's layout mirrors the constellation Llama, an animal sacred to their culture. This wasn't random. The Inca believed their emperor, the Sapa Inca, was the sun's mortal son, and Machu Picchu was his celestial throne room. What's truly remarkable is how they adapted to the mountains. At nearly 8,000 feet, the thin air makes stars appear brighter and movements more pronounced. The Inca turned this challenge into an advantage, using the jagged peaks as natural sightlines. Huayna Picchu, the towering mountain behind the ruins, functions like a giant gnomon, its shadow creeping across the city to mark time. Nearby, at the Temple of the Condor, a stone shaped like the bird's wings aligns with the Milky Way during winter solstice, when the Inca believed their ancestors traveled the celestial river. But here's the twist: Machu Picchu wasn't just an observatory, it was a living almanac. The agricultural terraces below the ruins are staggered at precise altitudes, each one calibrated to a microclimate that allowed crops to thrive at different seasons. The Inca didn't just predict the weather, they designed it, using astronomy to turn a vertical landscape into a breadbasket. Why does this matter now? Because the Incas' genius wasn't in their tools. They had no written language, no telescopes, but in their observation. They watched the same stars we do, yet saw a cosmos brimming with meaning. When you stand at the Intihuatana at dawn, watching shadows retreat from stone carved 6 centuries ago, you're not just visiting a ruin, you're stepping into a world where architecture and astronomy were one, where every wall, every window, every step was a verse in their hymn to the sky. High on the windswept plains of Wyoming's Big Horn Mountains, a circle of stones sprawls across the earth like a celestial fingerprint. At first glance, the Big Horn medicine wheel seems humble, just 28 spokes radiating from a central cairn, with smaller stone piles marking its perimeter. But stand here at dawn on the summer solstice, and the genius of its design comes alive. As the sun breaks the horizon, its light slices perfectly between 2 specific stones, casting a beam that points unerringly to the central altar. This isn't random. Every rock, every gap, every alignment was placed with purpose by ancestors who understood the sky's rhythms better than most modern city dwellers ever will. What makes this wheel extraordinary isn't just its solar precision, it's how it mirrors the stars. The outer cairns align with the rising points of Sirius, the brightest star in our sky, and Aldebaran, the fiery eye of Taurus. For the Crow, Shoshone, and other plains tribes who still gather here, these weren't just pretty lights. Sirius's heliacal rising marked the start of the buffalo hunt, while Aldebaran's appearance signaled when to move camp for winter. The wheel's 28 spokes, they likely track the lunar cycle, with each representing one day in the moon's journey across the sky. Imagine the generations of sky watchers who honed this knowledge, passing it down through oral tradition until the stones themselves became the library. But here's what's truly radical about the medicine wheel. It demolishes the outdated idea that advanced astronomy only existed in places like Egypt or Mesopotamia. Built between 300 and 1500 years ago, older than some pyramids, this unassuming stone circle proves indigenous North Americans were celestial cartographers long before European telescopes. Unlike monolithic observatories, its power lies in simplicity. No towering ziggurats, no polished mirrors, just rocks placed where the land itself becomes the instrument. The surrounding mountain peaks act as natural sightlines, framing celestial events like a Stone Age planetarium. The deeper mystery, we still don't know exactly who built it. Unlike the Maya or Inca, the wheel's architects left no written records, but the land whispers clues. Local tribes speak of it as a place where the earth and sky marry, where vision quests reveal cosmic truths. Archaeologists have found offerings, bundles of tobacco, strips of cloth left by centuries of pilgrims. Modern astronomers confirm its alignments aren't approximate. They're precise to within 1 degree, a margin that would have required decades of observation. Perhaps the most humbling lesson lies in the wheel's endurance. While modern observatories rely on fragile technology, this stone compass has weathered millennia without losing a fraction of its accuracy. It reminds us that astronomy isn't about gadgets, it's about patience, perspective, and the courage to look up. When you kneel beside its central cairn today, tracing the same stars ancient hunters once followed, you're not just seeing an old stone circle. You're touching a living covenant between humanity and the cosmos, written in the quiet language of rocks and light. At first light on the shortest day of the year, a miracle of stone and sunlight unfolds at Karnak. As the winter solstice sun crests the horizon, its golden beams arrow straight down the temple's central axis, piercing through colonnades and courtyards to ignite the sacred inner chamber where the statue of Amun-Ra once stood. This isn't poetic exaggeration, it's celestial engineering so precise that modern archaeologists needed laser theodolites to verify what the Egyptians achieved with ropes and shadows 4,000 years ago. The entire temple complex functions like a colossal sundial, with every pillar, every gateway, every statue positioned to mark the sun's journey through the year. What makes Karnak extraordinary isn't just its solstice alignment, it's how the entire site layers astronomy into its very bones. The famous hypostyle hall's 134 columns aren't randomly placed. They frame key stars in the constellation Orion, which the Egyptians linked to Osiris's resurrection. The sacred lake, its orientation matches the Nile's annual flooding, predicted by Sirius's heliacal rising. Even the temple's gradual eastward shift over centuries wasn't haphazard. Each new pharaoh adjusted the axis slightly to compensate for subtle changes in Earth's tilt, proving they understood axial precession millennia before Hipparchus discovered it. Now look beyond the architecture to the hieroglyphs. Those intricate carvings aren't just prayers, they're astronomical records. One ceiling panel depicts the zodiac with such accuracy that scholars used it to date the temple's construction. Another shows the moon's phases in a 35-day cycle, matching the lunar calendar still used in some African cultures today. The most haunting. A series of star clocks decorating priestly chambers, showing how Deccan stars used to mark nighttime hours shifted position over centuries due to Earth's wobble. The priests weren't just tracking time, they were documenting cosmic drift. Here's the revelation that rewrites history. Karnak wasn't just a temple with astronomical features. It was a living observatory where science and spirituality fused seamlessly. The same priests who performed rituals also calculated eclipse cycles, using the temple's alignments like a stone calculator. When they chanted about Ra's daily rebirth, they weren't speaking metaphorically. They were describing observable solar physics encoded in myth. The outer walls even feature what scholars call cosmographic texts, mapping the universe as a blend of physical reality and metaphysical belief, where stars were deities and light itself was divine energy. So why does this matter now? Because Karnak forces us to abandon the false divide between ancient religion and ancient science. These weren't primitive people worshipping the sun. They were brilliant observers who recognized celestial patterns and built a civilization around them. Every solstice alignment, every star chart, every carved constellation whispers the same truth. The Egyptians didn't just build temples to their gods. They built a stone dialogue with the cosmos itself, one we're only beginning to decipher. When sunlight floods Karnak's inner sanctum this winter solstice, it won't just illuminate ancient stones. It will reveal, once again, humanity's timeless urge to reach for the stars, not with rockets, but with reverence. The governor's palace at Uxmull doesn't just sit on the Yucatan landscape, it dances with the cosmos. At first glance, this 200-foot-long masterpiece of Mayan architecture appears to be just another administrative building. But look closer, and you'll discover its true purpose. A celestial observatory so precise it could track Venus's southernmost rising point to within a fraction of a degree. The entire structure angles slightly off-grid, aligning perfectly with the planet's most extreme position in its 584-day cycle. This wasn't guesswork. It was the culmination of lifetimes spent watching the sky, recording movements, and translating that knowledge into stone. Venus wasn't just another bright light to the Maya, it was the god Kukulkan in his celestial form, a deity so powerful his movements dictated war, agriculture, and even the timing of royal coronations. When Venus appeared as the morning star, it signaled the start of planting season. As the evening star, it marked the time for harvest. But here's what's truly astonishing. The Maya didn't just track Venus's appearances. They calculated its entire cycle, 8 years of risings and settings, with an error margin of just 2 hours across 5 centuries. Imagine doing that without a single telescope, relying only on notched sticks and shadows. The genius of Uxmull's design lies in its subtlety. The palace's facade features hundreds of carved masks depicting Chok, the rain god, but interspersed among them are Venus symbols, a visual code blending earthly and celestial power. The central doorway frames Venus at its southernmost rise, while the building's orientation creates a sightline that bisects the heavens like a cosmic ruler. Even the steps are calibrated. Their count matches the number of days in key Venusian phases, turning the architecture itself into a 3-dimensional calendar. But why go to such lengths? Because to the Maya, Venus wasn't just a planet, it was a harbinger of destiny. Codices like the Dresden Codex contain detailed tables predicting Venus's movements decades in advance, often tied to omens of drought, war, or prosperity. A rising Venus might prompt a king to launch a military campaign, while its disappearance could delay a sacred ceremony. The governor's palace wasn't just observing these patterns, it was harnessing them, turning celestial mechanics into political and spiritual authority. What modern astronomers take for granted with computer models, the Maya deduced through relentless observation. They noticed how Venus's path mirrors the sun's over time, how its conjunctions with other planets followed predictable rhythms. At Uxmull, they encoded this knowledge so deeply into stone that even today, when Venus rises at its southern extreme, the palace's alignment still holds true. Standing there under the same star, you realize this wasn't just architecture. It was a dialogue with the universe, one written in angles, shadows, and an unshakable faith that the sky held the answers to life's greatest questions. Rising from the jungle like a stone lighthouse, the Karakol Tower at Chichén Itzá stands as one of the most enigmatic structures the Maya ever built. Unlike the angular pyramids surrounding it, this cylindrical wonder curves skyward with narrow slit windows cut at precise angles, each one a telescopic portal to the heavens. Step inside during Venus's southernmost rising, and you'll witness a beam of light pierce through darkness to illuminate the central chamber floor. This wasn't architectural whimsy, it was celestial mathematics carved in limestone. The Maya didn't just track Venus, they worshipped its rhythm. Their Dresden Codex devotes 6 full pages to predicting the planet's appearances and disappearances with jaw-dropping precision. Why such devotion? Because in Mayan cosmology, Venus wasn't merely a celestial body, it was the god Kukulkan's battlefield. When Venus reappeared as the morning star after months of invisibility, it signaled the time for raids and conquest. The Karakol's windows frame these critical moments. One aligns with Venus's northern extreme, another with its southern, turning the tower into a stone calendar marking the planet's 18-month cycle. But here's the real marvel, these alignments weren't static. The Maya accounted for Venus's gradual shift across centuries, a phenomenon called precession that modern astronomers only confirmed with telescopes. Some scholars believe the tower's unusual spiral staircase mirrors Venus's retrograde motion, where it appears to reverse course in the sky. Others note how the structure's slight tilt matches the ecliptic plane, allowing priests to track not just Venus but also solstice sunrises and lunar standstills from the same vantage point. The genius of Karakol lies in its adaptability. Unlike rigid stone circles, its windows could be recalibrated by simply moving observing positions inside, an ancient equivalent of adjusting a telescope's focus. Archaeologists found evidence of wooden platforms that may have served as adjustable viewing stands, allowing generations of astronomers to compensate for subtle celestial shifts. This wasn't just observation, it was active dialogue with the cosmos. How did they maintain such accuracy without written manuals? The answer might lie in the tower's acoustics. Whisper at the base of the staircase, and your voice carries unnaturally to the top, a feature that may have helped apprentices learn complex astronomical chants verbatim. The Maya didn't need textbooks when the stones themselves could teach. Standing in Karakol's shadow today, you're not just seeing an ancient observatory. You're witnessing humanity's first planetarium, a place where architecture became astrophysics, where war and harvest dates were pulled not from almanacs, but from the silent dance of light through stone. The Maya didn't just watch the stars, they let the stars write their history. Carved from golden sandstone and frozen in mid-motion, the Temple of the Sun at Connach looks less like a building and more like a celestial chariot halted mid-journey. 12 pairs of intricately carved wheels, each 10 feet tall, flank its base, not mere decoration, but a stone clockwork tracking the sun's passage. At dawn on the equinoxes, the first rays strike the temple's eastern staircase, then cascade across the wheels in perfect sequence, illuminating each spoke like the hands of a cosmic timepiece. This isn't just architecture, it's solar poetry in stone, built 7 centuries before modern astronomy confirmed Earth's tilted axis. The genius lies in the details. Each wheel doubles as a sundial, their 8 spokes dividing the day into 3-hour segments, while the temple's 7 horse sculptures symbolize the days of the week. The main sanctum, now in ruins, once held a massive diamond that refracted sunlight into the inner chambers, creating prismatic displays during solstices. But here's what's truly astonishing. The entire structure leans slightly eastward, compensating for atmospheric refraction, so the sun's first light would hit the altar precisely at solar noon on specific festival days. Modern engineers using laser scans confirmed this tilt wasn't structural settling. It was deliberate, calculated down to the fraction of a degree. Step closer to those legendary wheels, and you'll find them carved with erotic scenes alongside astronomical symbols. This juxtaposition wasn't scandalous, it was sacred. The temple's builders saw the sun's journey as an act of cosmic creation, where light fertilized the earth just as human love created life. Every sculpture tells a story: serpents entwined around the base representing eclipses, dancers frozen in poses mirroring planetary orbits, even a hidden panel showing the moon's phases superimposed over the zodiac. Legends whisper that the temple once floated in mid-air, suspended by a massive magnet in its roof, a myth that might hold a grain of truth. Archaeologists found evidence of lodestone deposits in the ruins, possibly used in rituals where priests levitated metal icons using magnetic fields. Whether fact or folklore, one thing's certain: Connach was designed to move its worshippers both physically and spiritually. The main hall's acoustics amplified chanting to thunderous volumes during solstice ceremonies, while underground chambers funneled seawater to create cooling mists that veiled the sanctum in mystery. What rituals unfolded here? Ancient texts describe the Sandia Vela ceremony, where priests draped in gold-embroidered silks would chant as sunlight traveled across 365 carved panels, one for each day of the year. Offerings of rice mixed with mercury, believed to capture solar energy, were placed in copper bowls that still bear heat marks from repeated use, the most poignant remnant. A solitary wheel, perfectly aligned to cast no shadow during the summer solstice noon, a stone signature left by architects who understood the sun's language better than we do with all our satellites. Connach's final secret lies in its abandonment. Unlike other temples that fell to invaders, this one was deliberately buried under sand by its own priests when the main magnet dislodged, fearing its power could no longer be controlled. Standing before its ruins today, you're not just seeing a dead monument, you're witnessing a frozen moment when humanity didn't just worship the sun, they spoke to it in geometry, magnetism, and light, turning stone into a mirror for the cosmos itself. On the rugged island of Malta, where the Mediterranean sun beats down on golden limestone, the Mnajdra temples stand as one of humanity's most mysterious astronomical masterpieces. Built over 5,600 years ago, older than Stonehenge, older than the pyramids, these massive stone structures don't just face the sunrise. They conduct it. During the spring and autumn equinoxes, a blade of sunlight pierces through the main doorway, slicing precisely down the central corridor to illuminate a carved altar stone at the rear. On solstices, the light shifts to frame different megaliths, marking the year's turning points with the precision of a Swiss watch. This wasn't accidental architecture. These Neolithic farmers engineered their temples to function as both calendar and cathedral, where the sun itself performed sacred rituals. Who were these builders with such celestial knowledge? The temples predate metal tools, let alone written language, yet their alignments track solar movements with an error margin of less than 1 degree. Each massive slab, some weighing over 20 tons, was hauled from quarries miles away and positioned using only Stone Age technology. The southern temple's orientation is particularly ingenious. Its doorway aligns with the winter solstice sunrise, when the sun's lowest arc in the sky signaled the return of longer days. Inside, a pitted stone marker may have functioned as a primitive declinometer, helping priests predict solstices by tracking the sun's changing elevation. But Mnajdra's true brilliance lies in its layers of meaning. The temples aren't single structures but a complex of 3, each serving different astronomical functions. The oldest, built around 3600 BCE, focuses on lunar cycles. The middle temple tracks the equinoxes. the youngest and most sophisticated, constructed a few centuries later, masters the solstices. This progression suggests generations of accumulated knowledge, a Stone Age university where astronomy was passed down through the careful placement of rocks. What rituals unfolded here? Archaeologists have found altars with animal bone deposits, suggesting solstice sacrifices, and carved spirals that may represent the sun's cyclical journey. The acoustics are extraordinary. Certain chambers amplify voices at frequencies that induce trance states, hinting at shamanic ceremonies timed to celestial events. One haunting discovery, a stone slab with perfectly drilled holes matching the constellation Orion's belt, implies these people didn't just track the sky, they mapped it in stone. The greatest mystery isn't how they built Mnajdra, but why they abandoned it. Around 2500 BCE, the temples were suddenly deserted, their builders vanishing without leaving pottery, tools, or bones. Some scholars believe climate change disrupted their agricultural calendar, making the temples obsolete. Others speculate they were deliberately closed, their doorways blocked as if to preserve sacred knowledge. Whatever the truth, standing in Mnajdra's inner chamber today as equinox sunlight streaks across 5 millennia-old carvings, you're not just seeing an ancient calendar. You're witnessing humanity's first silent dialogue with time itself, written in sunlight and stone. Perched on a windswept ridge in the Bolivian highlands, El Fuerte de Samapota isn't just an ancient fortress, it's a stone cipher waiting to be decoded. At first glance, the massive sandstone outcrop carved with intricate channels and niches appears to be a ceremonial center or military stronghold. But shift your gaze upward at night, and the truth reveals itself. The site's alignments with the Southern Cross and Alpha Centauri aren't accidental. They're deliberate celestial markers etched into rock by the Chichén people centuries before the Inca arrived. This was a place where warriors watched the horizon for enemies while priests tracked the heavens for omens, blending defense and divination into a single sacred landscape. What makes El Fuerte extraordinary is how it transforms the entire mountaintop into an astronomical instrument. The carved throne at its summit isn't just a seat, it's a viewing platform where the Southern Cross aligns perfectly with distant mountain peaks during the winter solstice. Grooves cut into the rock channel rainwater into star-shaped patterns that mirror the Milky Way's brightest constellations during the rainy season. Even the site's notorious double-wall defense system has an astronomical secret. The narrow gap between walls frames the rising of Venus as the morning star, an event the Chichén associated with agricultural cycles and military campaigns. The genius lies in adaptation. Unlike flat desert observatories, El Fuerte's engineers worked with the rugged terrain, using natural rock formations as fixed reference points. One particular carving, a series of concentric circles, matches the sun's path during the December solstice, casting shadows that move like clock hands across ceremonial basins. Nearby, a peculiar zigzag channel aligns with the June solstice sunset, suggesting the site tracked both solar extremes. But here's the real marvel. Recent laser scans revealed hidden tunnels beneath the ruins that may have functioned as underground observatories, where priests could study the night sky protected from wind and enemies. Why combine astronomy with warfare? Because to the Chichén, celestial events dictated battle timing. The appearance of certain stars signaled the dry season prime time for raids when rivers were low. The Southern Cross's position indicated when to fortify settlements against invading neighbors. Even the fortress's location was strategic. Perched at the ecological boundary between highlands and lowlands, it offered clear views of both the sky and approaching threats. This wasn't just a temple or a fort, it was an early warning system where the stars themselves stood guard. The most haunting clue lies in the rock carvings of serpents and jaguars, animals the Chichén associated with specific stars. When archaeologists superimposed these carvings over star maps, they matched the constellations Scorpius and Lupus during key seasonal transitions. It suggests the entire site was a three-dimensional star chart where myth and astronomy merged into a single language of survival. Today, as the Southern Cross rises over El Fuerte's weathered stones, you can almost hear the whispers of ancient sentinels who understood that to control the land, you first had to read the sky. Buried beneath German farmland for nearly 7,000 years, the Goseck Circle emerges from the earth like a ghostly blueprint of the cosmos. This simple ring of wooden palisades, reconstructed now as stark timber posts, holds a secret that rewrote European history when discovered in 2002. Its southeast and southwest gates align perfectly with the winter solstice sunrise and sunset. Step between those gates on the year's shortest day, and you'll witness the sun's crimson arc framed like a fiery jewel in a Neolithic crown. But this isn't just an ancient calendar. The circle's precise 66-meter diameter, its concentric rings divided by radial spokes, even the peculiar clay-lined pits dotting its interior, all whisper of rituals that turned celestial mechanics into sacred theater. What makes Goseck extraordinary isn't just its age, built around 4,900 BCE. It predates Stonehenge by 2 millennia, but its eerie similarity to later monuments. The same geometric principles appear in Celtic stone circles and Egyptian pyramids, suggesting a shared astronomical knowledge that spanned continents long before written history. The circle's design is deceptively sophisticated. The gates don't just mark solstices, they create sightlines to track the sun's gradual shift across seasons, allowing Neolithic farmers to predict planting and harvest times with uncanny accuracy. Archaeologists found cattle bones arranged in solar patterns near the gates, hinting at sacrifices timed to celestial events. Even more chilling, fragments of human skulls discovered in the trenches suggest the circle may have witnessed rituals blending astronomy and mortality. The real genius lies in what Goseck doesn't have: no metal tools, no written records, no grand architecture. Its builders worked with nothing but wooden stakes and dirt, yet achieved alignments accurate to within half a degree. Modern experiments show the palisade's gaps functioned like a camera obscura, projecting sunbeams onto specific markers during equinoxes. The central ring's acoustics amplify whispers spoken at its heart, implying ceremonies where voices and celestial movements intertwined. Why would a farming community invest such effort? Because to them, the solstice wasn't just a date, it was a battle between light and darkness. Goseck's winter solstice alignment coincides with the sun standing still, a moment ancient Europeans feared might become permanent unless rituals coaxed the light's return. The circle's designers may have seen themselves as cosmic intermediaries, their ceremonies literally keeping the universe in motion. Today, as frost clings to the reconstructed timbers and the solstice sun once again pierces those ancient gates, Goseck's greatest lesson isn't about the past, it's about persistence. For nearly 200 generations, this unassuming patch of dirt held humanity's earliest known promise, that by watching the sky, we might finally understand our place within it. Deep in the Nubian desert, where the Nile carves its path through golden cliffs, the great temple of Abu Simbel performs a miracle of light that has awed spectators for 33 centuries. Twice each year, on February 22nd and October 22nd, the first rays of dawn pierce 65 meters through the temple's entrance, slicing through shadowed halls to illuminate statues of Ramses Roman II and the gods Amun and Ra-Horakhti in the sacred inner sanctum. But here's what defies belief. The seated figure of Ptah, god of darkness, remains forever untouched by the light. This isn't celestial coincidence, its stone-cold precision engineered by Ramses himself to showcase his divine kinship with the sun. How did ancient architects achieve such accuracy without GPS or computer models? The answer lies beneath their sandals. Recent excavations reveal the Egyptians used the desert itself as a drafting table. Archaeologists found grids etched into the bedrock around Abu Simbel scale models of the temple's alignment, where priests tracked the sun's path using obelisks as natural gnomons. These solar blueprints allowed them to calculate angles with nothing but shadows and patience. The February date wasn't arbitrary either. It likely marked Ramses' coronation, while October aligned with his birthday, turning the temple into a colossal birthday candle lit by the cosmos. The real marvel isn't just the alignment, it's how they compensated for optical illusions. The temple's axis angles slightly northeast because the builders understood atmospheric refraction bends sunrise light. The statues in the sanctum sit on a raised dais, ensuring the sunbeam strikes at exactly the right height after its long journey through the corridor. Even the doorway's trapezoidal shape acts as a filter, sharpening the sunlight into a razor-thin blade by the time it reaches the inner chamber. Modern engineers using laser theodolites confirmed the alignment's margin of error is less than 1/10 of a degree, a feat comparable to hitting a bullseye from 3,000 feet away. When the Aswan Dam threatened to drown Abu Simbel in the 1960s, an UNESCO relocation team faced an impossible task, preserving the solar phenomenon. They sliced the temple into blocks and reassembled it 65 meters higher, but recalculating the angles required astrophysicists to account for 3 millennia of Earth's axial precession. The fact that sunlight still pierces the relocated temple with perfect accuracy today is a testament not just to modern science, but to the Egyptians' original genius. Standing in that inner chamber as dawn breaks, watching sunlight creep across Ramses' stone face, you realize this wasn't just a temple. It was a time machine, a machine built to outlast empires, to carry one king's claim of divinity across millennia, written not in papyrus but in light and shadow. The sand may have held their blueprints, but the sky was their collaborator. Stretching across a barren Peruvian ridge like the spine of some ancient celestial beast, the 13 towers of Chanquillo stand as one of the most ingenious solar observatories ever conceived. Built around 300 BC, these stone sentinels form a perfect artificial horizon, a stone calendar stretching nearly 1,000 feet from end to end. Each December solstice, the rising sun aligns precisely with the southernmost tower, then marches northward over the coming months until it crests behind the northernmost tower during June solstice. The effect is breathtaking, nature's most powerful clock reduced to a simple game of light and shadow, where the sun's position between the towers could tell farmers within 1 or 2 days where they stood in the agricultural year. What makes Chanquillo revolutionary isn't just its precision, it's its democratic design. Unlike hidden chambers or priestly vantage points, these towers were meant to be read by anyone standing at the western observation platform. The entire valley becomes a sundial, with the sun's daily shift between towers visible even to untrained eyes. Archaeologists found ceramic offerings buried at the base, suggesting common people gathered here to mark planting seasons or festivals. The eastern observation point, meanwhile, tracked the sunrises, its alignment so exact that modern recreations show the towers dividing the solar year into intervals matching the Inca's later agricultural calendar. But who were these sky watchers? The towers predate the Inca by nearly 2 millennia, built by a culture so mysterious they left no written records. Recent excavations reveal a fortified citadel nearby, its walls adorned with carvings of warriors and celestial symbols. Some scholars believe Chanquillo's keepers were priest astronomers who wielded both military and spiritual authority. their ability to predict solstices granting them power over life-giving harvest. Others point to peculiar clay figurines found on-site, depicting figures with elongated heads gazing skyward, possibly representing stargazers mid-ritual. The real magic lies in the tower's imperfections. At first glance, they appear evenly spaced, but closer inspection reveals subtle variations in their gaps. These aren't errors, they compensate for the sun's changing speed across seasons due to Earth's elliptical orbit, a phenomenon formalized as Kepler's second law 19 centuries later. How did they achieve such nuance? The answer might lie in the surrounding landscape. The towers mirror the natural profile of distant mountains, suggesting generations of observation where the builders first tracked solar movements against terrestrial features before recreating them in stone. Today, as dawn breaks over Chanquillo and the first golden light slips between those ancient stones, you're witnessing more than an astronomical tool. This was a bridge between earth and sky, where farmers and kings alike could watch time itself unfold across a ridge of weathered rock. In a world without written calendars, these towers spoke the sun's language fluently, and 2,000 years later, their silent dialogue still echoes across the desert. High on Armenia's wind-swept highlands, where the Caucasus Mountains scrape the sky, the mysterious stones of Zorat's Kera stand like weathered giants frozen mid-conversation. Unlike the neat rings of Stonehenge, this sprawling field of over 200 basalt megaliths appears chaotic at first glance, until you notice the peculiar holes drilled through many of them at precise angles. Peer through one of these apertures at dawn during the summer solstice, and you'll witness the sun's first light pierce the hole like a laser beam, striking a marker stone nearly 200 feet away. This isn't random erosion. It's celestial engineering carved into rock 7,000 years ago, turning the entire plateau into an open-air planetarium. What sets Zorat's Kera apart isn't just its age predating England's famous stone circle by millennia, but its multifaceted purpose. While some stones align with solstice sunrises, others frame key stars like Vega and Deneb during their heliacal risings, events that marked planting seasons for ancient Armenian farmers. The most striking alignment occurs with the constellation Cygnus, whose stars shine directly through specific holes during midwinter nights. But here's the twist: several stones also point to lunar standstills, the moon's most extreme positions in its 18.6-year cycle. This duality suggests the site wasn't just a calendar, it was a sacred classroom where generations of sky watchers tracked both solar and lunar rhythms. The local name, Karahunj, translates to speaking stones, and the megaliths do seem to whisper secrets. Recent 3D mapping revealed that the holes aren't uniform. Their diameters vary to accommodate the apparent size changes of celestial bodies near the horizon, where atmospheric refraction distorts their shapes. Some stones even feature multiple holes at different angles, creating a stone spreadsheet where priests could cross-reference solar, lunar, and stellar events. Archaeocaustic studies added another layer. When struck, certain rocks produce resonant tones that may have been used in rituals synchronizing sound with celestial movements, turning astronomy into a multisensory experience. Who were these master sky readers? The site's builders left no written records, but artifacts found nearby, including Bronze Age tools and astral petroglyphs, hint at a culture that venerated the cosmos. One prevailing theory suggests Zorat's Kera served as both observatory and necropolis, with tomb orientations matching the same celestial alignments. Human remains excavated nearby show unusual cranial deformations, possibly ritualistic, echoing the elongated skulls found at other ancient observatories like Chanquillo. Standing among these stones today, watching twilight bleed into the carved holes like liquid starlight, you begin to sense their true purpose. this wasn't just a tool for marking time. It was a bridge between worlds where the living could commune with ancestors through the shared language of the night sky. The holes aren't mere sightlines, they're portals carefully drilled by hands that understood the heavens weren't just above them, but within them. Walking down the Avenue of the Dead at Teotihuacan, you're tracing a path laid out by architects who saw the earth as a mirror of the heavens. This 2.5-mile stretch, flanked by temples and pyramids, doesn't just lead to the Temple of the Sun. It points to the Pleiades, the glittering star cluster that rises directly over its peak during the city's founding era. To the Teotihuacanos, these stars weren't just celestial decoration. They were the divine architects of time itself. The entire city's grid aligns within half a degree of the Pleiades' heliacal rising, an event that marked the beginning of their agricultural cycle and the rebirth of the world. The Pyramid of the Sun, towering over the avenue at 216 feet, is more than just an imposing structure. It's a stone embodiment of cosmic mathematics. Its base perimeter equals exactly 896 feet, matching the number of days in the Mayan Tun calendar cycle. Climb its 240 uneven steps, a number corresponding to Venus's synodic period, and you'll find yourself standing on a platform that once held a wooden temple, its roof likely painted with constellations. But here's the revelation: the pyramid isn't perfectly square. Its western face angles slightly northward to compensate for atmospheric refraction, ensuring the equinox sun sets precisely behind its apex when viewed from the Temple of the Feathered Serpent. What ceremonies unfolded here? The murals surviving in Teotihuacan's lesser-known palaces offer tantalizing clues. One depicts a procession of priests wearing headdresses studded with star symbols, their arms raised toward a sky filled with dots representing the Pleiades. Another shows a jaguar, an animal associated with the underworld, emerging from a starry moor, possibly symbolizing the constellation's disappearance during the rainy season. Most haunting is the mural of the mythological animals, where creatures with celestial markings drink from rivers of light, suggesting rituals that reenacted cosmic creation myths. The real magic lies in the shadows, during the zenith passage when the sun stands directly overhead and vertical objects cast no shadow. The pyramid of the sun's geometry creates a fleeting illusion. For a few minutes, the structure appears to dissolve into pure light. Modern reconstructions suggest priests may have staged ceremonies where initiates ascended the pyramid during this moment, symbolically stepping out of the material world and into the realm of the gods. Nearby, the smaller Pyramid of the Moon aligns with the northernmost setting of the Pleiades. Its plaza, designed so moonlight during certain phases, would illuminate sacrificial altars in precise sequences. Why such devotion to these particular stars? Across cultures from the Maya to the Maori, the Pleiades were seen as celestial timekeepers, but Teotihuacan's innovation was turning their movements into urban planning. The city's sewage channels mirror the Milky Way's curve, while residential compounds align with Orion's belt. This wasn't just a settlement, it was a three-dimensional star chart, a place where walking down the street meant traversing the cosmos. Today, as dawn breaks over Teotihuacan and the first light touches the Pyramid of the Sun's weathered stones, you're not just seeing an ancient ruin. You're witnessing a civilization that didn't merely observe the stars. They built a city to dance with them, where every shadow, every alleyway, every painted mural whispered the same truth: the sky wasn't above them. It lived within their walls. Perched atop a volcanic ridge in what's now North Macedonia, the Chichén Observatory doesn't just overlook the landscape, it commands it. At an elevation of 3,300 feet, this Bronze Age marvel offers a panoramic view of the horizon so clear, you can almost hear the whispers of the astronomers who stood here 38 centuries ago. What appears to be a simple collection of weathered stones transforms into a sophisticated celestial calculator when the solstice sun rises. Carved niches and notches in the rock align with the sun's extreme positions, marking the turning points of the year with precision that would make a modern physicist nod in respect. The genius of Chichén lies in its simplicity. Unlike towering pyramids or intricate temples, this observatory relies on the natural contours of the mountain itself. 3 stone thrones, likely seats for priest astronomers, face eastward, their positions calculated so the midsummer sunrise would crest a specific notch in the distant hills, casting a blade of light directly onto a sacred marker stone. Another set of markers tracks the moon's 18.6-year cycle, a feat requiring generations of meticulous observation. But here's what's truly remarkable. The site's creators accounted for atmospheric refraction, the bending of light near the horizon, by adjusting their sightlines slightly higher than the actual rising point. This level of nuance, achieved without lenses or written records, suggests a deep, intuitive understanding of optics long before the concept was formally defined. Who were these sky watchers? Artifacts found nearby, bronze tools, ritual vessels, and ceramic shards hint at a culture that blended astronomy with daily life. The observatory sits adjacent to a settlement, implying that celestial events dictated not just religious ceremonies but planting seasons and communal gatherings. One particularly striking discovery was a stone altar with cup marks arranged in patterns mirroring the Pleiades, a star cluster revered across ancient Europe and Asia. During certain lunar phases, these depressions may have held liquid offerings that reflected the night sky, turning the altar into a mirror of the heavens. The mountain's strategic location reveals another layer of purpose. From this vantage, observers could track the movements of neighboring tribes using the same sightlines that mapped the stars, blending celestial navigation with territorial surveillance. Some researchers believe Chichén's priests doubled as early meteorologists, using cloud patterns over distant peaks to predict weather shifts critical for agriculture. The site's acoustics amplify sound unnaturally, suggesting ceremonies where chants echoed across the valleys, synchronizing human rituals with cosmic rhythms. What rituals unfolded here as dawn painted the stones gold? Perhaps initiates underwent trials under the solstice sun, or elders interpreted omens from the way shadows crept across carved symbols. The mountain keeps its secrets close, but stand there today as the winter sun aligns with Chichén's ancient markers, and you'll feel the weight of a truth etched in stone. These people didn't just watch the sky. They partnered with it, turning a bare ridge into a bridge between Earth and cosmos, one sunrise at a time. Rising from the floodplains of the Mississippi like the spine of a forgotten giant, the Cahokia Mounds hold secrets in their soil. At its peak around 1050 CE, this sprawling city, larger than London at the time, boasted a celestial secret, a vast circle of towering cedar posts now called Woodhenge. Picture 48 massive logs arranged in a perfect ring, their shadows stretching across the earth like the hands of a wooden clock. On the summer solstice, dawn would crest the horizon directly over a marker post, casting a long shadow that pointed unearly toward the central mound where the city's ruler likely stood. 6 months later, the winter solstice sun would rise in perfect alignment with another post, framing the shortest day in a geometry of light and timber. But here's what makes Woodhenge extraordinary. It wasn't just a calendar. The posts doubled as a ceremonial amphitheater, their arrangement creating acoustic channels that carried voices across the plaza with eerie clarity. Archaeologists found evidence of feasting pits between the posts, filled with the bones of deer and turkey, remnants of solstice celebrations where hundreds gathered to witness the skies turning. The tallest post, positioned due north, may have served as a gnomon for a massive sundial, its shadow dividing the day into ritual segments and buried beneath several posts. Bundles of arrowheads and mica sheets, offerings left by the builders to consecrate their cosmic timepiece. Who were these sky watchers? The Mississippians left no written records, but their astronomical legacy whispers through the artifacts they buried. Excavations revealed copper plates etched with circle and cross motifs resembling celestial maps, while pottery shards bear designs that mirror the Pleiades' rising pattern. The most haunting clue lies in the Birdman tablet, a carved figure with wings outstretched like a constellation, possibly representing a celestial deity or an astronomer priest who mediated between earth and sky. The real magic of Woodhenge lies in its impermanence. Unlike stone circles that endure for millennia, these cedar posts rotted away within decades, requiring constant renewal. Each replacement was an act of faith, a generations-long commitment to tracking the heavens. Modern experiments show the posts weren't just placed, they were tuned. Slight adjustments compensated for the gradual shift in solar alignments caused by Earth's axial precession, proving these builders understood celestial mechanics long before Copernicus. What stories unfolded here as firelight danced between the posts? Perhaps elders recounted how the world was born when the sun first aligned with the winter solstice post. Or maybe initiates underwent trials, fasting until the equinox shadow touched a sacred stone. The soil holds one final secret. Pollen analysis reveals Woodhenge stood at the heart of a celestial garden, surrounded by medicinal plants that bloomed in sync with astronomical events, a living pharmacy timed to the stars. Today, as archaeologists reconstruct the posts using laser-aligned cedar, you can stand where the Mississippians once did and watch the solstice sunrise pierce the modern replica. The effect is the same. For one breathtaking moment, the past and present align, and 400 years of silence dissolve in light. Woodhenge wasn't just an observatory. It was a cathedral of sky and earth, where time itself was measured in the growth of trees and the patience of those who listened to their whispers. At Karnak, the winter solstice doesn't just arrive, it makes an entrance. As dawn breaks over the Nile on the year's shortest day, sunlight pierces the temple's main gateway like a golden spear, racing down the half-mile axis to strike the inner sanctum where Amun-Ra's statue once stood. This isn't poetic metaphor, it's celestial choreography carved in sandstone, a light show engineered 33 centuries ago with an error margin smaller than the width of your palm. The entire temple complex functions as a colossal timepiece, its central avenue aligned to true north with a precision that would challenge modern laser levels. How did Bronze Age architects achieve such accuracy without magnetic compasses or satellite imaging? The answer might lie in the temple's own shadows. Recent excavations revealed hidden testing corridors where priests likely used plumb bobs and aligned strings to calibrate angles against the sun's path. The columns themselves tell a story. Their papyrus bundle designs aren't merely decorative. The slight taper of each pillar creates intersecting sight lines that functioned as a massive theodolite, allowing surveyors to check alignments during construction. Even the temple's flooring holds secrets. Subtle ridges beneath the sandstone slabs may have channeled water for leveling, turning the entire courtyard into a liquid horizon line. The real marvel isn't just the solstice alignment, it's how Karnak evolved. Unlike static monuments, this temple grew organically over 2,000 years, with each pharaoh adding new sections while preserving the original astronomical relationships. The famous hypostyle hall's forest of columns aligns with key stars in Orion, mirroring the constellation's position during the New Kingdom era. Later additions adjusted for precession Earth's gradual axial wobble, proving the Egyptians recognized celestial drift millennia before Greek astronomers named it. Walk through Karnak at twilight and you'll notice something eerie. The hieroglyphs covering every surface aren't just prayers, they're celestial records. One ceiling panel depicts the constellation Draco with stars placed so accurately, modern astronomers used it to date the temple's construction phase. Another shows a solar eclipse surrounded by priestly notations, likely the same event that darkened Egypt's skies in 1226 BC, the most haunting discovery. A hidden chamber behind the sanctuary containing a star chart carved in ebony, its inlaid silver dots marking stellar positions with a precision matching 19th century nautical almanacs. What rituals unfolded here when the solstice light flooded the inner shrine? Wall paintings show priests in leopard skins chanting as sunlight ignited censers of Kai-Fi incense, its fragrant smoke timed to reach the ceiling beams just as the sunbeams struck the altar. Sacred texts describe how the light would interact with gold foil layered on the god's statue, creating a dazzling refraction that seemed to bring the deity to life. Nearby, the sacred lake oriented to mirror the Nile's flood levels would reflect this celestial drama upward, completing a circuit of light between earth and sky. Karnak's ultimate lesson lies in its duality. This wasn't just a place of worship, but a working observatory where theology and astrophysics were inseparable. When the winter solstice sun climbs the horizon this December, its light will once again navigate those ancient corridors with perfect fidelity, a proof that some truths, carved in stone and aligned with the cosmos, outlast all empires. In the heart of Xi'an, where the echoes of dynasties whisper through ancient walls, a stone platform rises like a time-worn sentinel, the Ming dynasty's astronomical command center. Unlike the towering pyramids of Egypt or the sprawling temples of Mesoamerica, this observatory's power lies in its precision instruments, each one a masterpiece of bronze and mathematics. Step onto its sun-bleached stones, and you're walking among the tools that mapped the heavens for emperors, instruments so advanced they rivaled European technology centuries later. The star of the collection, the armillary sphere, a ringed marvel of interlocking circles that could track planetary movements with the delicacy of a Swiss watchmaker's finest work. What set China's astronomers apart wasn't just their engineering, it was their relentless documentation. While medieval Europe dismissed comets as omens, the scholars of Xi'an logged every celestial visitor with clinical precision. Their records of the supernova in 1054 CE, visible in daylight for 23 days, remain the most detailed account of what we now call the Crab Nebula's violent birth. But here's the twist, they didn't stop at observation. Hidden in the observatory's archives are star charts that prove they calculated the length of a solar year to within 26 seconds of modern measurements, all without telescopes, using only calibrated sighting tubes and abacuses. The real genius emerges in the instrument's dual purpose. The giant gnomon, a 40-foot sundial, didn't just tell time. Its shadow revealed subtle variations in Earth's tilt, allowing astronomers to refine their calendars generation after generation. The equatorial torquetum, a complex altitude azimuth instrument, could predict lunar eclipses years in advance by accounting for the moon's orbital wobbles. Even the simple clepsydra water clock linked timekeeping to celestial events, its drip rate adjusted seasonally to match the changing length of daylight. Why such devotion to the stars? In imperial China, astronomy was statecraft. The emperor's mandate came from the mandate of heaven, and celestial irregularities threatened his legitimacy. Xi'an's astronomers weren't just scientists, they were cosmic auditors, verifying the universe's approval of dynastic rule. When they recorded the guest star of 1572, now known as Tycho's supernova, their detailed positional data helped later astronomers prove the heavens changed, shattering the Aristotelian notion of an immutable cosmos. Today, as you run your fingers over the grooves worn into the equatorial sextant's bronze arc marks left by centuries of star sightings, you're touching more than history. You're feeling the patient pulse of a civilization that saw the sky not as a mystery, but as a manuscript waiting to be read. While Europe slept through the Dark Ages, the scholars of Xi'an kept watch, their ink-stained brushes tracing the universe's secrets one star at a time. Deep in the humid jungles of Chiapas, the Temple of the Sun at Palenque rises like a stone hymn to the cosmos. Unlike the towering pyramids of Tikal or Chichén Itzá, this intricately carved structure whispers its celestial secrets through shadow and symbolism. Step inside its vaulted chambers, and you'll find yourself standing at the intersection of Mayan astronomy and mythology, where the movements of Venus and the Sun weren't just tracked, but woven into the very fabric of spiritual belief. The temple's alignment is no accident. Its central doorway frames Venus at its brightest evening apparition, while the roof comb's lattice-like design casts shadows that slither like serpents across the steps during equinoxes. But the true masterpiece lies beneath the temple, the tomb of Karacol the Great, sealed under a 5-ton sarcophagus lid that sparked debates for decades. To casual observers, the intricate carving shows Karacol reclining on a cosmic tree, surrounded by celestial symbols, but look closer. The tree aligns with the Milky Way's position during winter solstice nights, its branches tracing the ecliptic path of planets. Karakol's posture mirrors the Mayan concept of the cosmic canoe, a vessel believed to carry souls through the underworld star rivers. Some researchers argue the entire scene depicts an ancient astronaut in a spaceship, a fringe theory, while mainstream archaeology sees it as a spiritual map of the cosmos, with Karakol's journey reflecting Venus's cyclical death and rebirth. The Mayan vision of the universe comes alive in Palenque's carvings. Their cosmos wasn't a void, but a layered realm, 13 heavens stacked above 9 underworlds, each governed by deities tied to celestial bodies. Venus wasn't just a planet, it was the warrior god Kukulkan, whose movements dictated the timing of wars and royal coronations. The Temple of the Sun's interior panels depict these beliefs in stunning detail. One shows the jaguar sun, a deity who transforms into a feline as it travels through the underworld at night, a poetic nod to the sun's daily disappearance and return. Another portrays the moon goddess cradling a rabbit, reflecting the Mayan explanation for the dark patches visible on the lunar surface. What's truly revolutionary is how Palenque's astronomers integrated these myths with precise science. The temple's staircases count the days between Venus's appearances, while hidden interior shafts align with Sirius's heliacal rising, an event marking the rainy season's start. Even the building's proportions encode astronomical data. The ratio of its height to base length matches the Venus-Earth orbital resonance cycle of 8 to 13. This wasn't just decoration, it was sacred mathematics, stone equations meant to synchronize human rituals with celestial rhythms. Standing in the temple's shadow today, watching twilight ignite the carvings with golden light, you're witnessing more than ancient art. These walls are pages from a 3-dimensional astronomy manual, where every glyph, every angle, every shadow was a sentence in the Mayans' ongoing dialogue with the cosmos. They didn't just chart the heavens, they danced with them, turning stone and starlight into a single, shimmering testament to humanity's eternal gaze upward. On the windswept Isle of Lewis, where Atlantic gales howl across the peat bogs, the Callanish stones rise like frozen giants mid-ritual. This sprawling cross-shaped arrangement of 54 megaliths isn't just Scotland's answer to Stonehenge, it's a lunar supercomputer carved from gneiss. While most ancient sites track the sun, Callanish dances with the moon, its central monolith and radiating avenues aligning perfectly with the moon's most extreme rising and setting points during its 18.6-year cycle. Stand here during a major lunar standstill, when the moon skims unusually low along the horizon, and you'll witness silver light pour down the stone avenues like liquid mercury, illuminating carvings of concentric circles that may represent lunar phases. The builder's lunar obsession reveals itself in subtle details. The tallest central stone leans slightly southwest, compensating for atmospheric refraction to frame the moon's southernmost rise. Surrounding stones form sightlines to distant mountains' natural markers that help track the moon's gradual drift across years. Recent laser scans revealed something astonishing. The circle isn't perfectly round. Its flattened side creates a viewing platform where observers could watch the moon's reflection ripple across nearby Loch Rogue, turning water into a natural astronomical instrument. Even the stone's shimmering quartz veins catch moonlight in ways that may have guided nighttime ceremonies. What myths unfolded under these lunar alignments? Local legends speak of the Shining Ones, supernatural beings who walk the stone avenues during full moons. Neolithic carvings found nearby depict crescent moon shapes alongside female figures, hinting at lunar goddess worship. The most haunting clue comes from a burial cyst discovered beneath the central stone, its occupant arranged in a crouched position facing the moon's winter rising point, as if awaiting rebirth in celestial light. The real magic of Callanish lies in its patience. Unlike solar events that repeat yearly, the major lunar standstill occurs just once every 18+ years. Building a monument around such a slow cycle implies generations of precise observation passed down through oral tradition. Modern astronomers confirm the alignments aren't approximate. They are accurate to within half a degree, a precision that would have required decades of moonrise notations. Today, as fog swirls around the stones and the northern moon paints their surfaces silver, you're witnessing more than an ancient calendar. This was a stage where the moon itself performed, its light creeping between stones to touch hidden carvings, its phases marking the passage of lifetimes rather than days. The Callanish stones don't just track celestial mechanics, they capture the moment humanity first realized the sky's rhythms were slow enough to outlast them, yet predictable enough to build eternity around. At the heart of the Inca Empire, where the Andes scraped the sky, the Coricancha Temple of the Sun stood as the crown jewel of Cusco, a place where gold didn't just adorn the walls but became the walls. Imagine sunlight striking its facade, ricocheting off 700 solid gold plates, each one hammered to perfection so the entire structure blazed like a second sun. This wasn't mere opulence, it was celestial mimicry, an architectural echo of the god Inti, whose light sustained crops, kings, and cosmic order. Step inside during the June solstice, and the real magic unfolded. Sunlight funneled through trapezoidal windows to ignite a golden disk at the temple's center, its reflection splashing across polished silver altars like liquid fire. The effect was so dazzling, Spanish chroniclers claimed the interior glowed even on cloudy days, a feat of engineered radiance that left conquerors trembling. But the Coricancha's genius wasn't just in its glitter. The temple's alignment with solstices reveals a deeper sophistication. The eastern wall angles precisely to catch the first rays of the December solstice sunrise, while the western gate frames the June solstice sunset, dividing the year into agricultural epochs. The Inca didn't just mark these events, they lived by them. Terraced farms surrounding Cusco were planted according to solstice shadows cast by the temple's pillars, turning stone and sunlight into a farmer's almanac. Even the famed Inca road system, thousands of miles of engineered pathways radiated from the Coricancha like cosmic spokes, with way stations positioned to align with key stellar risings. Walk the temple's perimeter today, now fused with the Santo Domingo convent after Spanish colonizers built atop its foundations, and you'll find whispers of its original purpose. The remaining walls curve slightly inward, a design quirk that compensates for atmospheric refraction, ensuring solstice alignments remain true across centuries. Hidden drainage channels beneath the floor once carried ritual offerings of chicha maize beer to sacred springs, timed to lunar phases. Most haunting are the ushnas, stone platforms where priests tracked celestial events using gold-flecked water basins, early reflecting telescopes that turned the night sky into a shimmering mirror. The Coricancha's true legacy lies in how it wove astronomy into the fabric of daily life. Every Inca city had its own version of the temple's alignments, creating a synchronized network where planting, festivals, and even tax collection revolved around celestial cycles. When the temple's shadow touched a specific marker stone, farmers knew to plant quinoa. When Venus appeared in a certain window, it signaled the emperor's ceremonial bath, a ritual cleansing tied to the planet's 8-year cycle. Even the gold itself held astronomical meaning. Its imperishable glow symbolized the sun's eternal return, a promise etched into the walls that light would always conquer darkness. Today, as solstice sunlight still slips through those ancient windows now framing Catholic altars, the Coricancha whispers a lesson modern societies often forget. That time isn't just measured but felt. The Inca didn't just build a temple to the sun, they built a civilization that moved to its rhythm, where every shadow, every harvest, every prayer was a verse in an unbroken hymn to the sky. The rolling hills of Ireland's County Meath hide a secret older than the pyramids, the Lufkru Cairns, where 5,000-year-old stone whispers the language of the equinox sun. At dawn on the spring and autumn equinoxes, a beam of sunlight pierces the narrow passage of Cairn tea, crawling inch by inch across the chamber floor until it ignites a series of cryptic spiral carvings on the backstone. This isn't just light hitting rock, it's a Neolithic alarm clock, a celestial trigger designed to mark the moment when day and night hang in perfect balance. The precision is humbling. The tomb's entrance aligns with the equinox sunrise to within half a degree, a feat achieved without compasses or written records, just generations of patient observation etched into the landscape. Step inside Cairn Tea's cramped passage, and you're walking through a stone telescope. The corridor narrows precisely to frame the rising sun, while the chamber's corbelled roof, a masterpiece of Bronze Age engineering, funnels the light like an optical instrument. The illuminated carvings aren't random art. Recent 3D scans reveal the spirals encode a sophisticated counting system, possibly tracking the 19-year metonic cycle of the moon. One particular symbol, a series of concentric circles with radiating lines, matches the sun's position during the winter solstice when viewed from a nearby hilltop, suggesting the cairns were part of a larger astronomical network. What rituals unfolded here as the equinox light painted the stones? Bones excavated from the site show signs of ceremonial placement, with skulls oriented toward the illuminated carvings. Offerings of carved stone balls, each with exactly 56 knobs, a number that divides neatly by lunar phase counts, hint at a culture that saw mathematics as sacred. The most haunting clue lies in the equinox stone, a slab where sunlight only touches a carved solar symbol at midday on the equinox, proving the builders accounted for both sunrise and solar zenith in their designs. Lufkru's true genius emerges when you view the cairns as a collective. The 32 surviving tombs form a pattern mirroring the Pleiades star cluster's position 5 millennia ago, with Cairn T aligned to the constellation's heliacal rising. Nearby, the Hag's mountain summit offers a vantage where the equinox sun appears to roll down the hillside, a phenomenon that may have inspired the local legend of the Kalich, a goddess who shaped the land by dropping stones from her apron. Standing in that ancient chamber as equinox light spills across spirals carved by hands long turned to dust, you realize these weren't just tombs, they were libraries. The stones don't just mark time, they converse with it. Their carvings a Rosetta Stone for a world, you where death, astronomy, and the land itself were threads in the same unbroken tapestry. The light that reveals their secrets today is the same light those builders chased 5,000 years ago, a bridge across millennia written not in ink, but in shadows and stone. The story of ancient astronomers isn't just carved in stone, it's written across the collective memory of humanity itself. From the solstice-aligned temples of Egypt to the lunar tracking cairns of Ireland, these structures reveal something profound. Our ancestors didn't merely observe the cosmos, they conversed with it. Without satellites or calculators, they decoded planetary movements with nothing but patience and persistence, turning boulders into celestial calendars and mountain peaks into natural observatories. Their greatest achievement wasn't just architectural, it was intellectual. The Maya predicted Venus cycles within hours over 5 centuries. The builders of Mnajdra tracked solstices to within 1 degree using nothing but Stone Age tools. These weren't primitive people guessing at the sky. They were scientists in the truest sense, recording, testing, and refining their understanding across generations. What's most striking is how these cultures, separated by oceans and millennia, arrived at similar revelations. The Nebra Sky Disk's golden stars mirror the Pleiades carvings at Lufkru. The same 19-year lunar cycle appears in Babylonian clay tablets and Celtic stone circles. This wasn't coincidence. It was the inevitable result of humans everywhere turning their gaze upward with the same burning questions. When do we plant? When do we harvest? Where do we fit in this vast cosmic dance? Their solutions varied. Some built towering pyramids, others arranged humble stones, but their purpose was universal. Yet ancient astronomy wasn't just practical, it was sacred. The Inca didn't merely track the sun, they believed their emperor was its child. The Egyptians didn't just note Sirius's rising, they saw it as the goddess Isis heralding the Nile's life-giving floods. This fusion of science and spirituality holds a lesson modern society often forgets, that wonder and calculation aren't opposites but partners. The Mayan scribes who painstakingly recorded Venus movements also composed poetry comparing its glow to a jade bead tossed across the night sky. Today, as light pollution erases the stars for a third of humanity, these ancient sites challenge us to reconnect with the sky's rhythms. Modern astronomy has given us breathtaking images of distant galaxies, but we've lost something those cultures nurtured. The intimate, bone-deep knowledge that we're part of the cosmos, not just observers of it. When you stand in Chanquillo's shadow and watch the sun rise between towers as people did 23 centuries ago, you're not just seeing an ancient calendar. You're touching a thread that connects every human who ever looked up and felt the stars pull at their soul. Perhaps their greatest legacy isn't in the alignments we can measure, but in the questions they still inspire. How did they achieve such precision? What secrets did they take to their graves? Most importantly, what might we rediscover if we learn to watch the sky with their patience, their reverence, their hunger to understand? The stones they left behind whisper that the universe still has stories to tell, if only we remember how to listen. From the towering pyramids of Giza to the whispering stone circles of Karnak, these 26 ancient observatories form a global tapestry of celestial wisdom, each thread woven with the same unshakable truth. Humanity's quest to understand the cosmos is written into our very bones. What's astonishing isn't just the precision of their alignments or the beauty of their designs, but the sheer diversity of their approaches. The Maya carved Venus's path into limestone towers, while Bronze Age Europeans tracked lunar cycles with golden discs. The Inca turned entire mountains into sundials, and Neolithic farmers marked equinoxes with spirals lit by dawn's first light. Different cultures, separated by continents and centuries, all reaching the same profound revelation that the sky wasn't just a mystery to solve, but a story to join. These builders left us more than ruins, they left a challenge. In an age where satellites map the heavens and apps predict eclipses, we've gained convenience but risk losing something vital: the intimacy of standing beneath an open sky, feeling the universe's rhythms in our marrow. The astronomers of Chanquillo didn't just calculate solstices, they celebrated them with feasts under the stars. The priests of Karnak didn't merely record celestial events, they turned them into sacred theater where sunlight resurrected statues of gods. Their genius lay in merging observation with wonder, mathematics with myth. As we swipe through digital star charts today, let's not forget the patience that carved these stone libraries. The Nebra Sky Disk's creators spent generations refining its design. The builders of Mnajdra hauled 20-ton slabs without wheels or metal tools. Their legacy whispers that true understanding isn't just about data, it's about devotion. Whether you're an amateur stargazer or someone who's never paused to glance upward, these ancient sites invite you to reclaim that connection. The same stars that guided Polynesian navigators and predicted Nile floods still shine above us, waiting to share their secrets. So the next time you step outside at night, try this. Turn off your phone, let your eyes adjust, and imagine you're standing beside a Mayan priest tracking Venus or a Celtic elder counting lunar cycles. The constellations haven't changed, the questions haven't either. What stories might we uncover if we approach the sky with their curiosity? If this journey through humanity's first observatories has sparked your imagination, hit like, subscribe, and tell us in the comments which site left you awestruck. The cosmos has been our shared classroom for millennia, and class is still in session. Keep looking up. The next chapter of the story is yours to